So today we want to talk about some of the standards that are out there, some of the ports and connections, license and what version you might have, some gauge and firmware stuff, just an overview of automatic testing, the custom report features, and I'm going to kind of actually do what is usually considered the death of a webinar, which is to do a live test and open up the application live and kind of go through it so people can kind of see what's on there and how really user friendly it is. When you first open it up, it can feel overwhelming, but my goal is to kind of reduce some of those fears and let people know it's actually very user friendly. Retrotec offers several different, I would say, versions of the FanTestic software. And I got another slide that kind of gives you some more details on what these are and how they actually work. So if you get FanTestic Lite and the first time you download it, you have free full version, 30 days, 24 fans, all the standards. You get the whole gamut. You get to do whatever you want with the FanTestic Lite for your first 30 days. After the 30 days, you must register your free version. Even though it's free, you must register it, and then you get to use one fan and one standard of your choice, but you do not get any custom reports. So the free version allows you to basically just test, but do not allow you to use any reports. If you do upgrade to the pro version, which is 2 vans, then you purchase a license and you pick a standard that you want to use. And again, for the free version, you also pick your choice of the standard you want. And you also now get to do 2 fans and do custom reporting, which means you actually can modify the report with your own logo and all the different things that would make it seem more personable for you and your company. If you really are doing more, multi-fan, large building, multi-family kind of stuff, then again, you're going to purchase a license, but you get all of the standards, whether it's 6 or 24, and you get, of course, the custom reports that are on there. You can install your license on 5 computers, which people find to be very valuable for their staff or knowing that they may have a couple computers. So when you go to do your testing, you have this already installed with your license in case one of your computers is not acting correctly, as sometimes they do. So let's talk about the version of FanTestic. So at the very top, it tells you what version it is. Sometimes it may have additional numbers, like right now, this is 5.8.11.37. And depending on how you opened it, whether it was a user or administrator, it may have slightly different numbers, but the first few numbers and the ending kind of give you an idea about what you're after. What you can do if you're not sure if it was an update that you missed is you can actually under File, go down to check for updates, and it will tell you that your software is up to date or tell you a new one needs to be downloaded. And if you're online when you first open it up, it actually checks it automatically. But just in case, you may not have been online when it first opened, and you can check for updates. You can also go to the Retrotec website and under software, under products, you can actually find, is your software up to date? And it's got the entire gamut of software. So all of the FanTestic and any of the other software you may be using, Virtual Gauge, is all listed there and what version it is. And you have access to download any updates that or new software that you're looking for. These are the standards that are included or with the larger license, the 6 or the 24 license, or you can actually get as a Lite or your Pro 2 version. You can pick one standard. So usually it depends on kind of where you live or where you might actually be selecting what standard you're going to use. So I just want people to see that these are the standards that are already built into FanTestic automatically. And you can, so if I bought my purchase and let's say I used the Lite or I had a Pro 2 version, then you would really be just picking one of these, and that's the standard you'd have all the time that was built into FanTestic. But these are your options that you can choose from. Most people in the US are going to be picking from ASTM 779. That's the most common one that's out there. But if you're going to do an Army Corps or you're required to do Army Corps testing or you follow that protocol, then you have that option. Otherwise, it's basically a regional based on your region where you're at. And do note that there is a manual for and in your language that actually works for whatever standard you're at. So you can see the different types of European standards, EN 13829, and there's one for Sweden, there's one for France. There's a report that you can customize depending on which version you buy or use for free. Then you have those options. So I can tell you, I don't do quote prices or anything like that or keep track of them, but just to get the pro version, which is the 2 fans, is a very reasonable price for what you get out of the report software that's in there. So just kind of some overviews about what FanTestic does. I will kind of go through some screens, and then in a minute I'll get this PowerPoint out of the way, and I'm going to open it up and kind of go through the actual software live. So some of the stuff will seem kind of very stale, but you can kind of see. We definitely will go through it live and how that works. So it is really one of the fundamental and easiest to use software package out there to do automated testing. It's as simple as you confirm the standard you have. Most people will have one. You tell it to find your gauges, and it finds them, and you begin. It really is that simple, and we're going to show you how that works. It has a variety of features, from seeing your test history with pictures of each test that if you put those in, it calculates your results in various ways and confirms that you actually followed the standard at the bottom. And we'll show you what that means on some of the tests. One of the things that makes this thing very useful is that you can actually hide sections that I don't need. And again, you can see that as we come up here with the live version. But the goal is you can actually get rid of stuff that actually may seem overwhelming. Like I don't need to keep certain things live and active in front of me when I'm trying to do a test. So here's my equipment that would show up, and I can actually just focus on the equipment that's there, the gauges, and automatic will find them, or I can add a fan. These are a variety of things that are easy to do and very intuitive. I will go through that. I don't recommend it, but you do need to understand that there are ways to make sure your standard is reset, or if you do need to alter your standard for some reason, we're going to pop up that menu and actually show you how that works. I'm going to do it today because we don't have time to do a full gamut ASTM test or Army Corps test, so I'm going to shorten some of the parameters and then show you how to make sure they get put back to normal. There's an enormous amount of analytical tools that are embedded in there. Some of these I may not have time to really cover all today. This probably would be more like a 4-hour class if we had time to make sure you left with good examples of all the different features that are in here. My goal is you get a good overview about the fact that this actually is an easy to use application, and it really fulfills a major need that the industry has been after, and that is simple automatic testing that follows a standard and can confirm if you deviated. So these are some of the newer graphs that have been added to the software, whether you're using the SMACNA standard or the ASTM standard or one of the European standards. All of these have been built into that. So this has one of the most amazing report generating software packages that I've actually seen or worked with. So I will be upfront. I don't use FanTestic every day. I'm mostly doing more training, so I train with it or use it, but it isn't something that I run out every day and use. So I actually make sure that I stay kind of in touch with it or on top of it. But the reports that come out of here I used to do home inspections and mold inspections and a variety of stuff. And this is definitely way beyond the things I used to use for that in terms of how simple and easy it is to do. So I do the test and I say, create a report. And all the things that have been built into the report are created based on your standard. So there is a different report for an ASTM standard versus a Army Corps standard because they have different data and different requirements. So each report is generated. So if I had a duct test, it actually generates an entirely different report. So it's not a generic report that says, here's your data and let me help you figure it out. It actually is designed to work with each standard that's on there. And you can customize them. So, the picture that I had in the application that I did for that house, I can now also go to customize report template, and I can change stuff around. I can add my own logo. I can change any of the phrase or information that's on the template, or I can even delete any of the information that I feel is not really necessary for how I'm going to use my report. So it generates a variety of data automatically, and I can say, no, I don't need this table, or I don't need that data. And you can take it out and save this as a separate template. All right, let's move into some of the connections in basics. In fact, wait, you know what? I'm going to go to the live section here real quick. So let's close this down and
So Joe, this is the webinar equivalent of a spacewalk here. So we wish you luck. Ground
Yes.
control to Major Tom.
Yes, thanks. It is. If you don't, maybe you've seen some webinars, and it is typically I've learned it's a no-no to try and do anything live because for some reason the webinar gods are not with you, and things always crash or have problems. So it's always a great webinar when at least one thing crashes. So let's hope that we don't have that today, but it's not uncommon. So a minute ago, I mentioned that you can actually close all of these different parameters or different areas and then open them up as I need to. And it's designed to go down the row and work with it in the same order you would do for your test. All right. All right. So I'm going to close off everything so I can open them up and explain what we have here. Um, So the first one at the top, it's actually going to ask me, and I already did. I brought one up just so I can actually have some information entered, so I wouldn't be spending time entering addresses and stuff. So this is an ASTM E779-10 test. All right. If I had a license and I had other different standards I could use, I would open up a new test with a different standard and begin that test. You can't switch your standards in the middle of your test. It does ask me to select a building image, so I can go to where my pictures are in my uh, on my uh, PC and pick a picture. We'll say that's the picture for the house I'm going to test. Say OK, and that basically is it for the top section. Basically, just confirms that I am doing the right standard. So let's go to the equipment part. So it asks, well, who's my technician? Is there a reference number? Maybe this is some report number you may use for your business. And then I already opened this up and I asked it to find gauges. So I'm going to have to, let me just do this. Once I have found my gauges and I have data, which I didn't think I had any data, I guess I do, then it says you cannot find gauges anymore. So what I can do just for the simplicity of it is I will close this. It'll ask me to save it. I say yes, and I'll open a new one just so you can kind of see how we find gauges. So you can see my other tests are here. So I can say I'm going to have a new ASTM test, and it comes up. And again, I would actually do find my building. We'll go ahead and go through this. We'll say it's this building. I say okay. And again, I'm done with the top here. Now we can open up the next section, which is the gauges. So I have 3 gauges in my office right now that I have set up, and I'll go through the wiring options. But you can actually use USB or you can use Ethernet. We don't recommend you use Wi-Fi. You can, but Wi-Fi can have little glitches that you don't notice, and your data may be paused, or you may not be connected to the gauge, even though we always think of Wi-Fi as being a constant connection. So when I go to hit Find Gauges, I can either add a fan or mostly use just start. You go Find Gauges, and it says, "Are you sure you want to do this?" Because it's going to erase the gauges I've already got and begin to go search for them. So I say okay. And it's searching and it found the 3 gauges that I have in my room. All right. So I can see where each one of them is and has a serial number on the back. And it tells me what fan they actually have on their display of each one of the gauges. And each one of the fans, I can enter the serial number if I needed to, but that's actually something I cannot find directly. But it did find the serial number of the gauge. And I can also put down where these are. So I can say this is the front door. I can say this is on the 3rd floor. And I could say this is on the 5th floor. All right, pretty exciting. Now, once I found my gauges, I can move down to the building. So I can describe this as a 2-floor, 2-story, uh, and address. So I want to avoid this, but in order to go through the scenario, I'm going to go ahead and do it for you. So 1, 2, 3, and we'll call it Main Street. Um, Colin, is there anything you want to add while we're entering this thing to kind of go through the doldrums here about some of the things you've been working on and why this took so long to do and how intense it was to create this program?
You mean why it took so long to evolve FanTestic?
Yeah, or just how much you guys have put a lot of time and effort into this, and it really has come together as a phenomenal resource. But it actually, maybe you can share how difficult it is to do software. Maybe that would be good.
Well, I think we started on this version in 1995 or so. So we've been on this for, had a programmer working on it continuously for 20 years. Not necessarily full time. We have someone on it full time right now who's been on it for several years. So it's not a kind of a minor thing. Um, I guess there are less complicated software out there that don't do as much. But FanTestic is an amazing tool that does a huge amount of work for you. And you alluded to the time saving that the generate report feature does. It basically takes a 2-hour job and turns it into a 10-minute job. So once you get your template set up, that is an amazing tool. So apart from that, that's all I would have to say about it.
Well, great. I'm done with my little thing. So on the right here, it's asking some very specific information that you need to enter in order to make sure you're able to do all of your calculations. Can I ask you to mute, Colin? Thank you. So it wants to know that you need to know a few things in order to follow this ASTM standard. So the only thing is asking you when you do this standard is the things that are required for that standard. It doesn't ask for any information that's not specific to this one. So this one's asking for sea level, building height, enclosure volume, and a floor area. So one of the things that I didn't have, I have slides to do this, but I thought I'd talk about the software first, was that you can do air changes per hour, which is very common, and many of the folks that are out there are used to doing air changes per hour when they do a blower door test. You can also do more of a commercial style, which is surface area, which is all 6 sides of the box, and how much leakage I have per square foot. So there's different ways that it can do it, and this can do it all of them all together, but it needs some of the information that's on there. So the floor area is actually the floor area of the, as you may think of it for a duct test. So it's a 2 floor, so each floor is 1,200. The enclosure area is all of the surface area from all of the sides that are exposed from unconditioned to conditioned area. So all 6 sides, the floor, the ceiling that goes to the attic, that's my total of enclosure area. And my volume is the same thing many people are used to using when they deal with air changes per hour. All right, we'll scroll down. Okay, so
Joe,
yes, sure.
it should be mentioned here that if you are doing a test, let's say like air changes, and you want air changes at 50 pascals or something like that, that requires volume. If you enter the volume, it will give you air changes. You don't necessarily have to put in the surface area of the building to run the test. If you do put in the surface area, it will give you results that are based on surface area. If you put in none of those areas, it will give you a warning, and it will give you, let's say, equivalent leakage area or CFM at 50 or whatever, that don't require any of those areas. So just because it's asking for those areas, you only put them in if you want results that use those areas.
Great, thanks for that information. So I'm going to go ahead and close the equipment section down and the building details so they have all of those filled out. And now we're into the test section. And you don't have to tell it whether you're going to pressurize or depressurize. You're going to just tell it to go do a test, and it knows what are the pressures that are going to be for that test. All right. So I do need to confirm my temperature. So 68. Well, it's kind of chilly here in Atlanta, and my wife doesn't believe that the thermometer should ever reach 68. So I'm going to make that 64. Probably 63. And my outdoor temperatures today are probably around we'll just say 40 degrees, let's be safe. For those of you that are in northern climate, I feel for you. I used to live in Chicago. I understand what you guys are going through right now. So let's just go through again some other stuff that's on here. It's got my date. It's got the time. It asks where the operator is located. Sometimes you may do a multifamily, and it's easier to be outside controlling this versus inside, and all of your fans are directed a certain way. We can talk about tubing later, but this wants to know where you're located. Also, would be where you're located. Usually, is also where your gauges are. Is more of it. So I may be outside, but your gauges may be inside. But it's after wants to know where your gauges are located. I can enter the data manually. So for some reason you just wanted to open the software with the free version, enter the stuff that you gained from your gauge and wrote everything down diligently, you can do that. Some people may find that actually is more of an exercise that is frustrating, but maybe something happened that day and you weren't able to do a connection and you just do ahead and go do things manually. It is available. All right, and but we're going to capture data automatically. And I'm going to do is I'll show you under this. There's several tools up here, so I'm going to go through the tools at the top just so we're familiar with them. At the files where most of the things are, and that's where I can do the typical save and open recent tests. Here's where I generate my reports or view the reports in the directory or customize them. You can also export an Excel data file, so it's an Excel file, and look for updates or USB drivers. So there are some valuable things that show up under there. I can show my test history or auto hide it. That basically is the history that shows up in the beginning with the pictures. I can do a new set, which actually is a set of data, which we see here in the main screen. And for the tools, number of fans calculator will be coming soon. There's actually something you can download directly from Retrotec. I'm sure Jay's going to now search for the link and send that to you. You can also calculate and update durations of the test. And here's one of the ones that's under settings. If I wanted to change the standard for new tests, which means every time I open this, it's going to be an ASTM test, or maybe I now want to do SMACNA each time I open it so I can determine that license detail. Maybe I change my language. And under advanced is where I can actually have some significant control. So I'll try and move this down so we can see the window. It wants to know, should I give me some warnings about taking a baseline before or after? Colin doesn't really like it. I like to, as a reminder, it's kind of a preference to remember that you need to uncover your fans if you're doing that. Show calculations warnings, which means if you have a warning with one of your fans is not reaching test pressures or you have the wrong range. And the graphs, whether they include all the individual or show average points. And at the bottom, I have some illustrations here and a few that will talk about gauge control versus common or individual. So one is when things are set for common, they actually will be using the primary gauge as a scenario, and other gauges will be working off of that same fan speed to make it simple. Or I do individual, which means that they are all working as individual gauges with individual fans, and sometimes they can actually challenge each other. At the top here, I actually also have settings. This is where you can modify some conditions or kind of get into trouble. So I can hit at the top, what I just did, which is reset to the standard defaults. So this is ASTM 779 standards, and these are all the conditions that are required by the standard, which says it's going to take 12 baselines for 10 seconds each. On the next line, it'll say it'll take 11 induced pressures from 60 pascals to 10 for 20 seconds each. And then in the bottom, it says that when can I gather my data? Like if maybe I'm trying to get to 60 pascals, but I'm only at say 55. This actually will determine that you need to be within 15% or 3 pascals. All right. So that determines when you can actually start gathering your data, and within a sample of 20 of them. So it says within 20 readings, if I'm this close to my test pressure, I can gather my data. And these are the defaults. The other one is how stable does my gauge need to be in order for it to begin testing or do my baseline, which means that I need to have a difference of 1 pascal over 5 seconds. So you can't have your gauge fluctuating with pressures in order to do your baseline. It really wants to make sure your gauge is stable before it does a baseline or starts your test. On the upper right here is from basic stuff as to, do I want to measure my air changes per hour at 50? A lot of these are just kind of given. I don't really change any of the parameters that are usually on the right side here. Sometimes you may actually get other systems where you're going to reference 75 pascals. European standards may have something that's completely different, but in general, for the ASTM, we're referencing 50 pascals. So notice that our induced pressure is going to go from 60 down to 10. And what we want to do is make sure we started at a low pressure and went above the 50 Pascal reference that we're after, so we can actually get a range above and below that. If I were to just close this and do the test, it would probably take maybe 10, 15 minutes, depending on the challenges that the fan had to get up to each one of the pressures and speeds. So what I'm going to do is alter the parameters so that I can actually run a test and we can not sit here and watch this go for the rest of the webinar. So I'm going to tell, instead of taking 12, I'm going to ask it to just take one baseline for 5 seconds. And if you're learning this, it does help to actually modify some of these things so you understand what the parameters are that you normally have. So I'm going to just tell it to take 3 points, all right? And I'm going to just reverse it so it doesn't get so loud too quick. I'm going to have it go from 20 pascals to 60 pascals. And the reason I'm only doing this just so I can do a quick test and you can see how the data gets used and how simple it is to do a test, all right? When I'm done, I want to make sure I go back and hit reset standard defaults, because if I do this test and I save it and I close it, the next time I open it, it will use these parameters. Again, I'll say that again. These parameters are now part of my ASTM test once I close it and save it. So I can open this up next week and hit find gauges, go test, and these are the parameters that it actually is stored for this version. It's very crucial that you remember that. So if you alter anything, it's important that you reset the standard so that you can make sure you're testing for that standard itself. Okay, I'm going to close this out. All right, so now I simply have found my gauges. I entered my building information. I confirmed that I was going to do a certain type of test, and I hit begin auto test. So it's searching for the gauges, make sure everything is making its connection. And here's the reminder that it said. It says, please uncover your fans. And it's preparing the gauges, making sure that they are reading stable numbers, and then they can begin their baseline. Normally for this, we would actually have had 12 baselines, and it still will do a pre and a post baseline, but my goal was we didn't stand here trying to find something to talk about while it did a bunch of baselines. Okay, unseal your fans and continue. And so what's going to do right now, you may hear the fans in the background. I apologize for the noise, but the goal is I have 3 fans in the room. They're basically duct testers that I've converted to work on act like a blower door so that they don't get too loud and they all fit in my office basically. So they're all set to the B range. And now they're going to establish the first test pressure, which is 20 pascals. And it's not uncommon that it can overshoot those pressures. So what we see in the red, that just went from red to gray, it says that the top is actually the pressures that are in the room compared to outside. So it says in the beginning, your pressures that you had in your room with the gauge compared to outside were not close enough to your main gauge, but now they actually have fallen into place. So I have some slides later, which we're going to come back to that. So if you remember the red that showed up, we're going to talk about what that means in terms of where your fans are located, or that they're not actually able to gather the right data, or maybe there's something that's separated with their tubing. So again, you see it says 26.6 here at the top where it has its induced pressure. And remember, we gave it the ability to go above and below 15% or 3 pascals to gather data in order to perform the test. So the next one, it says, okay, I'm going to try and do a 40 Pascal test, and that's actually here it's telling me what's happening up here in the main section. And one of the things I can also do is watch the test over on the side. I'm going to open up the gauge display, and I can actually see the pressures that are on the individual gauges, and I can actually drop down to each one of them and see what kind of pressures or what kind of CFM is showing up on the individual gauges. So this is a really cool feature on the right-hand side here. Okay, so I've got my first 2 points completed. Remember, I only told it to do three points, so we can kind of move through this fairly quickly. So what I have now is my last test, which is going to 60 pascals. So make it a little loud. I apologize. It shouldn't last for a few seconds, and I can explain why we got the data. So on the side over here, you can see where my mouse is. It actually is showing you the different gauges, and I can see what the pressures are and what their CFM is. It also tells me if I'm not at test pressure or how far off I am in terms of a percentage. And then it it was able to get the test pressure, gather its data, and I can see the results that I'm getting per individual gauge. Notice we have a difference from the two gauges here of probably close to almost 1,000 CFM. Okay, it says, okay, my test is done. We're going to do a baseline after the test, a post baseline, and it asks you to seal everything up. So I go around and make sure the fans are sealed, and then it can actually wait for the gauges to stabilize, and it'll actually kind of flash saying they're not ready yet, and then it'll do its post baseline. So you can see just how simple it was, that the only thing I had to do was set up my fans, connect the gauges. We'll talk about some different options on how to do that, and hit begin test. And now I have a completed test. If I had followed the original ASTM, all of these fields across the middle here would all be filled in, and I would actually have data that I could begin to then just create a report. So at the bottom here, I want to open up the bottom and show you what's down here. It explains that there's actually a deviation statement. So there is no pass and fail for the ASTM test because it doesn't have like a number that you should pass, whether it's air changes per hour or volume per square feet. So but what it does have is that you followed the standard based on how it was written. So it says tested in both directions. That's the requirement. We did not. All right. So there's a temperature difference and a height ratio from outside. It says you've met that. My outdoor temperature between 45 and 95, and it is not. I did not do enough baselines, or did I do? I did do my readings at 10 seconds. So whether or not you completely adhere to all of the deviation statements is based upon your test requirements or your standard that you're going to do with your client or how you perform this test. Sometimes it may not be possible to do a pressurization test. Maybe it's a hospital, or maybe there's some other conditions that don't allow that. So you're after the data and determining if it actually is passing what your requirements are. So let's scroll back up, and I can show you that over here my results are based upon the information we put in the building. Remember our square footage and enclosure. I can actually see my air changes rate is 10.53. So definitely not a well sealed up structure that we have here. And you may be looking for flow enclosure at CFM per square foot. 0.4 is kind of the higher range of that. And this is, again, leakage per surface area of the structure. And just above that, I have my air change rate of 10.53. So depending on what type of results you might be looking for, there's various that convert this into square inches per 10 pascals or 4. If you're familiar with that, then you understand how they apply. Some of those are Canadian or lead type of results. And so this is my set that I have, and you can tell at the top it says it was depressurization. And if I needed to, I could go back down and say I need a new set, and I could add another test set of parameters. All right. Yes.
Hey, Joe.
Yes.
If you could slow down a bit, like maybe 25%, you're going pretty fast. So I think that some of the people that aren't English speakers as their first language have trouble keeping up with you. There's a couple points since I'm on the line. Obviously, when you were talking about gauge control, that's only appropriate when you're running more than one fan, which you are, of course. But from testing from high pressure to low pressure, there's a few important things you need to know about that. And in the defaults, what we do is we put our recommended test pressures and test pressure sequence in there for each standard to give you the maximum chance of passing a test. And the reasons why we go from low to high are many. One is it will achieve 60 pascals faster than it would achieve 10 pascals, so it's faster. The next point is that if you need to test to 60 pascals and you set it you start at 10, maybe it stops at 25, it can't get any further, so this way you find out whether you can actually achieve 60 pascals. The other is if something's going to open up in your building, you find out right away that, oh, a door blew open and so on, and you don't wreck the test. So you find out on the very first test point that that all your windows and doors are closed properly, nothing's going to pop itself open. And the final point there is that if you're running your fans at maximum speed, if you get them all overheated at low speed and then try to run them at high speed for your final point, you might have a good chance of blowing the breaker. Obviously, with small fans, it's not a problem, but often when you're doing a multi-fan test, particularly in the US at 120 volts, there is a good chance you're going to pop the breaker. So you want to get that point established first. Once you achieve your highest test pressure, then there is less heating involved on the breaker, and much less chance that you're going to pop it mid-test and destroy your test. And the other one is, I don't know whether you want to go into this right now, but there's a series of steps that you can follow that will allow you to check out each fan and its pressure circuit and its response to test speed before you start the test. So do you want to talk about that later?
I don't have a slide for it, but if you want to go ahead and just, while you're on the line, just go ahead and talk about it.
Okay, it is something that you can demonstrate, and essentially what you do there, if you can just on your screen get rid of the that little setup window. Okay, so if you go to another test, like start new set, for example, and if you open up the show gauges display on the right hand side, there you go. We go into begin semi-automatic test. So if you can click on that. So right now, if you look on the right-hand side, you can see that we're on gauge serial number ending in 78. So what we can do here is we can set a target pressure of, let's say, 60 pascals on that particular gauge, and we can adjust the fan speed and see if that whole gauge circuit is actually working. So if you want to do that, Joe, you can run that.
So what I did here in the middle was select the gauge that we have over on the right side showing my pressures. I gave it a target pressure of 60 and asked it to begin running that fan with that new target pressure.
Okay, and then just try adjusting your fan speed, and you can see there that.
Try to do speed or pressure? I have pressure set here.
Well, actually, it's already operating, so
yeah.
It's clear that yes, it can achieve 60 pascals. It's achieving. You can see it overshot there a little bit. It's now at 61.7. So what that's telling us is that fan is working on both channels. Channel A is giving you the pressure, channel B is giving you the flow, and using the same method you can go and you can check each one of your fans individually to see whether it's working. Like, it's quite possible that a tube might be disconnected on one fan, the wire might not be connected, and you can run around and check all of your fans individually by simply changing the serial number over on the right-hand side for the display and over on the semi-automatic. So let's say, for example, you've got one fan at the top of a 10-story building. Instead of running back and forth or using radios or whatever, you can use this feature to run that fan throughout its range, check to see that it's working, it's giving results, shut it down, and then check the other fans before you press fully automatic. Does that make sense?
It does to me.
In the past, I didn't even know about this until yesterday, amazingly enough, and I'm the one who's been sponsoring the software for the last God knows how many decades. What we have been telling people to do in the past is to use virtual gauge, which does this and a little bit more, but essentially does the same thing. The problem is if you open up two software versions, like Virtual Gauge and FanTestic at the same time in your computer, it will lose connection with one of them. It will only operate one of our software systems at one time. So if you happen to be running FanTestic and you decide, aha, I'll open Virtual Gauge to check out my gauge, then it'll close the connections off to FanTestic, and that is a tech support issue that I wanted to bring up because people will be in the middle of the test, they'll open up Virtual Gauge and the whole thing will stop. So this particular feature that I just showed you, you can operate prior to doing the fully automatic mode, and it's a great way to check your system out.
Yes, great.
Anyway, that's
I didn't know that. I've always used the virtual gauge.
Yeah, well, until yesterday, I talked to the software developer and I was complaining about the this problem, and she said, "Oh, just use semi-automatic and use the window on the right." I went, "Oh, really? No one had ever told me you could do that." So big news for everybody today.
Great, great. Anything else you want to add to it, Colin?
No, I think that's enough for now. You can carry on.
Thank you. So before I close out the application itself and grab a few slides, is there any other questions about the software or things on the software that I can answer any questions for anybody, or Colin or Jay can answer?
There was one question that someone answered about pressurization or depressurization. There's a real problem with people deciding it's going to be a pressurization test because sometimes they are incorrect in their assumption of what pressurize is and what depressurize is, depending on whether they're standing inside and outside of the building. So in this software, all you have to do is to correctly answer the question, are the gauges inside or outside the building? And to hook up the gauges correctly according to our tubing diagrams, which means the red tube always passes through the red panel from inside to outside or outside to inside. It's a red tube that goes across the building. As long as you do that, it will always tell you whether you are pressurizing or depressurizing. Now, if you're going to be doing a manual test where you're entering the numbers in manually, then you have to tell the software that it's actually seeing a negative pressure if negative is what shows up on the gauge. So if you're inside the building and you say, I'm at minus 60 pascals, and you put in minus 60, it will tell you you're depressurizing. If you forget the minus sign and you put in 60 pascals, it will say, aha, you're pressurizing. Now, all you need to do is to put the minus sign on the very first number that you put in for channel A reading, and it will put a minus sign on every number thereafter. So that's an important point to remember whenever you're doing a manual test.
Great. All right, so I'm going to close this down, and I can bring it back up if we need to. And I'll bring up the PowerPoint. So I got about 4 minutes or something before the top of the hour. So for those of you that may need to leave at the top of the hour, you still get your credits for BPI. We appreciate that, but I'll probably go a few minutes over. And for those of you that can hang on, we appreciate your patience. So these are the gauges that you can use with FanTestic software. And it depends on which way you're going to wire them, is depending on how you're going to use them. And so the DM32, hey Colin, can I get you to mute?
Yeah, I just wanted to make a point on one of the questions that was answered by Nigel. He said, do the fans work together to create the overall test pressure within the building? Yes, they do. So if you've got 3 fans on the bottom floor, they all work together to create the pressure. If you've got a fan on the 3rd floor, it works together to operate or to create the total pressure. Now there's a different I think the response that was given to this question was a little bit misleading. As far as the gauge control, whether you have common control or individual control, if you've got a fan on the top floor, that particular fan needs to be on individual control. If you have it on common control, then it will be running more or less at the same speed as all the other fans, and it may over pressurize or under pressurize the top floor. There's a whole section in our manual on how that should be set, and it's probably one of the single biggest mistakes that people make. So if you've got, let's say, 3 fans running in the same on the same floor, they have to be on common control. Otherwise, one fan will take over and one might actually stop. So you can either do this in the software, or you can do this by wiring the fans in such a way that they're hardwired together. So when you daisy chain fans together, as I think Joe's probably about to tell you, then all those fans are common, meaning the same control signal goes to each fan. When one fan increases in speed, they all increase in speed. If you set them on individual control, which essentially means, you know, set to pressure on each individual fan, then they can go out of sync with each other. Go ahead, Joe.
Great, thanks.
Hey Joe, before you get started, I want to give everybody the section and the and the manual that you'll be reading from. This is actually on from the multiple fan manual, and it is page 15, section 5, and that is called the multiple fan testing scenarios. And I can send that link to everybody.
Okay, so I will try to show us the differences in some of the wiring diagrams and some of the tubing diagrams that may help or still confuse people that are out there. So there's different ways of actually connecting your fan to your gauge or multiple fans together. So what we talked about a second ago was this individual control, which we kind of see more on the right, and this common control, which we see on the left. So on the left, if you notice that the only thing we have here are the control wires that are controlling the fan. There's no tubing that's on here. So it just shows that I'm controlling on the left, that the top gauge controls one fan and all the other fans are then controlled automatically by the top gauge. I still have all the other gauges that will have tubing connected to them because they need to read the pressures. And they all have a blue tubing at the connection at the bottom. That's actually the Ethernet, which goes back so I can actually control these gauges. So on the left is actually your series or common control. On the right is an individual control. It depends on your setup on how you're doing it and whether or not you would need one or the other. Okay, so it's not uncommon that people may have 2 fans or 3 fans all together. It's not as common it happens, but I try to use this as an example. So I've got all of my connections that go back to my Ethernet hub and to the router and ultimately to the computer. And I'll finish off with that as a final note on this one. And then really what you can do is you're going to have your connections that are going from one fan to the other, just as I illustrated on the previous slide. But this would be the way you would actually set these up as all 3 fans each need a gauge. All those gauges need to come back to the computer so I can know what they're reading. But only the top gauge, or it could be any one of the gauges, is controlling all 3 of the fans. So they're all actually moving together, not trying to battle each other. Or what you can find is that one of them may begin to move slower and slower, and it ultimately could begin to move backwards. So here we've got them all, and they're all moving together because they're all being controlled by one gauge. So I wanted to make a point down the bottom that for those of you that are still learning this or need this, that I could have 2 gauges, 10 gauges, 25 gauges, and I need to have them all being put into an Ethernet hub. And you can have multiple hubs that then all ultimately go into the router. The router is one of the last things that determines the network assignment to each one of the gauges. No matter how many gauges you've got, the router is the one that says, oh, this one gets this number, this one gets that number. They're all assigned, and then your computer with the software can now control all the different gauges because they've all been assigned a network assignment, a number. So this kind of tries to illustrate what happens if you did not do scenario where I actually had individual control. And what can happen is that the fans could then slowly begin to slow down, or one can actually begin to go backwards. Sometimes it's not apparent when you have these 3 fans stacked, but you may have 3 fans here, and you may have another hallway that's 10 feet away. Then the fans are actually in this common zone, and they're fighting each other. So that's why common control is a much more better way to set these up so the fans are not fighting each other. And again, I can actually do this in the computer with my selections, or I can actually wire them in a way that allows them to do that. So this would not be the way to set that up. And here you can kind of conceive just from the scenario that one fan starts much sooner than the other, and it can actually be going negative. It can actually be drawing more air out of it than and backwards the wrong way than what you'd started. These are some slides that I brought up when Colin started to talk, and these are individually controlled, individually wired, and one fan can actually overpower the other. It's not that uncommon that it takes about anywhere from 30 seconds to a couple minutes, and the other one begins to slow down and actually can go backwards. So here I took off individual control. It's now called common control. You have the one or the other. You can't choose both. So I showed you that on the drop down. So I have common control set, and now even though they're not wired, the fans are not wired together, the software can say, oh, I'm going to make the fan on the bottom do the same thing that the fan on the top is doing. And you can see why there's times where you may want to use individual control depending on the zones or how you're doing your performance test. You have different options for connectivity between whether it's the DM32, whether it's Wi-Fi or not. Clearly you can't have Wi-Fi if it's not a Wi-Fi gauge. Most of the people that are in this are using Ethernet or they're using USB. We really discourage you from using it. And again, the Ethernet is on the bottom, not on the top. The top, which I popped up in the corner there, is where you connect for the gauge to the fan itself. And on the bottom is usually it's blue. Depending on what color you use, it doesn't really matter. But the bottom here, you can see in the lower right corner is where your USB or your Ethernet gets connected. You can use Wi-Fi. We kind of discourage it just because it actually has pauses or small glitches when you're actually doing your data gathering. Ethernet, it's unlimited the amount of gauges you can have between hubs and final router, and the links are basically 100 meters or 325 feet with one wire. And once you add power hubs and other options, it's almost limitless. USB is limited by around 15 feet, and you can go up to 5 links of those. So the DM2, the older gauge, only had a USB connection, so you mostly had your gauge near your computer because of the issue with the length of USB, and had to run very long tubes and umbilicals all the way up to your fan. And now with the DM32, you can leave your gauge right at the fan and just run an run a Ethernet all the way down, just one cable. Usually it's to a hub, and then run one all the way down. So it may have 3 fans on the top floor, but I only need to run down one Ethernet from that hub to able to access it from the computer. So one of the things that's out there is a number of fans calculator. You can download this from the Retrotec website. It's on the support software and drivers page. And what it actually does is allows you to enter the size of the house, right, and enter in blue the results that you're looking for. And then in green will give you the number of fans that are needed to perform your tests. There is so you can download to fill out a field check for your gauge, and it kind of gives you basic information about how to connect the tubing, check the tubing, enter this form and your name and date, and you can document that you've been checking your gauge regularly. We kind of moved to just using the yellow tubing with the umbilical because lower doors and duct testers all have one same common length, so it's easy to actually check your gauge and do that. Some of the issues that also are common for people that are doing tests where they have a lot of tubing is that water or moisture or small little debris can be blocking your tubing. That's why you want to check your tubing in a similar manner you would check your gauge with your umbilical, all with the gauge by checking pressure to pressure to make sure your tubing is not blocked. The firmware needs to be up to date. It's 2.4 build 71B1, and there's lots of places where you can actually check it on the the splash screen, the first home screen, or on the very last page. You can under settings, you can confirm what version you have on your gauge, and if you need to, you can update it with the firmware that you can download from Retrotec. And again, you're going to use a USB to make this connection to make sure you have the most up-to-date firmware. The new DM32 controls energy conservatory fans. And if you're going to do multiple fan testing, this is actually an incredibly valuable tool to use the software, because you may have several energy conservatory fans, and you may have a few Retrotec fans. But if you have enough gauges for each fan, you can actually use the software. You cannot use the energy conservatory gauge, but you can use the Retrotec gauge, and the DM32 will control the TEC blower door completely automatically, as though it was a regular Retrotec fan. So if you're looking for additional fans to do a large multifamily or large building tests, you can get some additional fans that are energy conservatory and make your system work. And you can also do a trade-in if you have multiple DG700s that you're no longer using, or a DM2 that's a little older. It's a phenomenal price. I'm not sure how much longer they're going to be continuing to do this, but it is a great way to upgrade your gauges. Now, I'm just going to go through tubing real quick to understand some of the differences that are out there. So we talked about how you connect your gauge physically from the gauge to control the fan. The difference is that these are the tubing connections that happen. And again, each gauge must have the tubing connection. Again, yellow goes to the yellow fan. If you have a high-powered fan, it has a yellow and a green. I tried to keep things simplified by just having one set of tubing showing that each fan must have a tubing connected to it in order to get the readings back to your software. Now, on the other side, on the red, where I'm actually using my reference outside, these are what gets combined. And depending on how you follow your standard, there's different ways to have your tubing outside, whether it's teed in multiple directions, whether you're trying to get all four sides. Those are your determination on what your standard requires or what your protocol is. In general, though, this is where you're going to make sure all these tubings are teed together and connecting. And another option is on the interior is I may want to combine all of the interior tubing, which on the blue side, I may send that to one location, or I may send it to multiple locations. And this is one of the pictures at the bottom showing the challenges with the, all the different tubing and all the different logistics that have to happen when you do these types of tests. So if I did decide to separate my individual tubings to, like, say, different floors or different parts of the structure, so I can confirm that I was getting good pressures on the 8th floor as the 4th floor and the 1st floor, just to make sure this is the things that can actually happen in the report or generate when I do my software, is it can actually say, wow, your fan number 2 and fan number 3, their pressures are too far off in the room compared to what your main gauge is. So these are some of the things that actually help make sure that you're doing a proper test. It should be less than 10% from any part of the structure itself. So when you spread out your input throughout the entire structure, I can confirm that I'm able to comply with the guidelines that go along with most standards. The last one I'll touch base on is that make sure you have enough power for what you're going to do. So some people may decide that they need 4 fans to do a multi-fan test, but realize that there's hardly any power in the lobby or any power somewhere near there. And that many of these fans really should have their own entire circuit, that the 2 of them are going to blow a 20 amp circuit. That's common for most of any fan you would use. So you need to make sure that you have the right amount of circuits, know where the breakers are, have access to them, and if you're going to have extension cords, that they're also rated for the right size. That is my last slide. What are some of the questions we can answer?
Joe, can you talk about when people would use Wi-Fi?
Sure. Yeah, I just saw that question. So if you wanted to do a single test, single fan, basic test using FanTestic, you could use Wi-Fi. But you may find that it may take a little longer to do the test because it may be pausing every now and then to make sure it always has connection. So it can be done, but usually you want to make sure that your gauge and is close to the proximity of how you're going to do your test. So if they were just 10 feet away, you probably would be able to maintain a solid connection. But some people are another floor with their gauges or other parts of the structure, and that would not be the proper way to use Wi-Fi. You could use Wi-Fi for a variety of other things from your either your phone or your tablet. Can you do well with Gauge Remote to kind of confirm you have connections or see what they are, but you can't use them simultaneously. So you can use it as long as you're in a close proximity. A common way to do that would be maybe a multifamily test where the doors are right next to each other and you're sitting right outside and you're going to do your test. Clearly, Wi-Fi probably could work well, but you're just better off just if it's that small and short, just connecting the wires.
So, so essentially, when the operator is moving around, like let's say, for example, you're doing a combustion blind zone test, and you're walking around the house, you're opening and closing doors and so on, then you can do this by having your cell phone in your hand. You can be watching the pressure and so on, so you don't want to be dragging tubes all over the place. But if you're dealing with a static situation where the components, the gauges, etc., aren't moving, you might as well hardwire them together, even if that gauge is, like, say, on the third floor or something. You want to hardwire them together because you're not moving around. So it would be more as to whether you wanted to see results when you were in motion, which is a great application for Wi-Fi. Would you concur with that?
Yeah, I do indeed.
Um, okay, Dan was asking about customizing our reports for duct testing. And yes, you can customize the duct testing report in exactly the same fashion. The first thing you would do is to do a duct test, generate the report, take a look at it and say, okay, how would I like that to be different? And at that point, you can open up the template and you can start changing the template. So you would name the template Dan's duct test report #1 or something. So after you, at that point, ask to generate the reports, it will ask you if you want to use the standard template or the new template you just created. And what I do is I start making small changes, and then I keep generating the report over and over so that I can see those changes be reflected through the template. The first thing you might do is to put your company information in there, maybe a picture of you, your equipment, whatever. And then each time it generates the report, that will be in there, so you never have to put it in there again. And then slowly build up the report, changing page breaks or whatever you need to do, taking sections out, adding them in. One thing that you might find confusing is that when you're operating the template, it shows the data as a field, so it's kind of a thing with a funny name on it and brackets at either end. And what that means is that whenever you see that in the template, it takes the number from your test and pastes it into that spot in the template. So you can't really go wrong here. You can start kind of playing around with it, make some changes and see what it does until you get it down to the point where it's something that you want. And you could easily spend a couple hours modifying your template till you get it perfect. But once you complete that process, your test report is simply a matter of going click and you're done.